Section 6.6b is about solving real-world problems using inequalities. So we're going to graph some of those. Our example says Rosa Padilla sells radio advertising in 30-second and 60-second time slots. During every hour, there are up to 15 minutes available for commercials. How many commercial slots can she sell for 1 hour of broadcasting? First thing we're going to do is we're going to figure out what our unknowns are. We're going to come up with an X and a Y. And in this case, we want to know how many commercial slots. There are 2 commercial slots. There's a 30-second commercial slot and a 60-second. So we'll let X be the number of 30-second slots. And we will let Y be the number of 60-second slots. Okay, so those are my 2 unknowns, the values that I want to look at. Very often in word problems, you're gonna face things that I like to call purchase problems, problems that end up multiplying how much something is worth times how many there are. And like I said, this is very famous when you're purchasing things. If you're purchasing t-shirts, how much does each t-shirt cost? How many are you buying? You multiply those values. So we're going to use that value here to make some equations. She's going to sell radio advertising in 30-second time slots. Now 30 seconds is how much each of those time slots are worth. And then how many is my X value. So I'm going to do 30-second time slots times X. That's how much of that they're worth times how many. Plus 60-second time slots times Y, because that's how much times how many. And the question is, we have to be up to 15 minutes. So we got to be under 15 minutes. There's an inequality. Now this inequality isn't quite right. And the reason it's not quite right is because these numbers are seconds, 30 and 60, and 15 is in minutes. And you can't mix your two units. So what I'm going to do is I'm going to turn 30 seconds into minutes. So 30 seconds is a half a minute. So 1/2 X. 60 seconds is 1 minute. So 1Y is less than 15 minutes. So there's my equation. Okay, how much times how many for the commercial, 30-second commercials, how much times how many for the 60-second, and it all has to be under 15 minutes because it says up to. So this is my inequality I'm going to use. I'm going to now graph a boundary line. So I take 1/2 X plus Y equals 15. And now I'm going to isolate the Y by subtracting 1/2 X. So we get Y equals negative 1/2 X plus 15. So now we need ordered pairs for this. In real world problems, I like to use the X and Y intercept. So I'm going to plug a 0 in for the X value. Gives me a 15 for Y. And now what number could I put in for X that would give me a 0? So what if I did 30? 30 for X, because 30 divided by 2 is 15. Negative 15 plus 15 is 0. So those are my two intercepts. Now I'm going to go over here and label my graph. The X is on the bottom and the Y is on the side. You might be wondering why we're only using a first quadrant graph. And the answer is when you're doing a real world problem, you always stay in the first quadrant because your answers are always positive. You know, how many commercial slots? Well, you can't sell -6 commercial slots. So we don't care about the negative answers. All we care about the positive answers. Now I've labeled my X's from each mark is going to be worth 2. That gets me to 30. And I've labeled my Y's with each mark equaling 1. And that'll get me up to 15. So now I'm going to graph these points. Here's 0, 15. And here's 30, 0. So now I'm going to connect the dots by making my boundary line. Notice it's less than or equal to, so my boundary line will be solid. And so there's my boundary line. Last thing I have to do now is figure out the shading. So I'm going to try 0, 0 into the original. 1/2 times 0 plus 1 times 0 is less than or equal to 15. 0 plus 0 is less than 15. That's true, which means 0, 0 is on the true side. Since 0, 0 is under here, that means I'm going to shade under here. So there's my graph of this inequality. Now what does it tell us? It tells us that any of these combinations in the blue will work. So we could buy 10 30-second time slots and 9 60 seconds. We could do that. We could buy 1 30-second and 13 60 seconds. But what we can't do is we couldn't buy 20 30 seconds and 7 60 seconds. That's in the bad area. And so you can kind of get a visual representation of this real world problem because we've graphed the inequality. Here's another real world problem. It says Coach Riley wants to take her softball team out for pizza and soft drinks. She doesn't want to spend more than $60, and we have to write an inequality. Well, here's some important information. The large pizzas cost $12, and the soft drinks cost $3. Now, to me, that looks like a how much each thing costs. And in here, we want to find how many pizzas she buys and then soft drinks, which means I'm going to let X be the number of pizzas and Y the number of soft drinks. Now let's write an inequality. Pizzas cost $12, so how much times how many? Soft drinks are $3, how much times how many? And we can't spend more than $60. Sounds like less than or equal to me. So that's the inequality we're going to graph. We start by graphing our boundary and setting it equal to 60 temporarily, and then isolating for the y. So 3y equals negative 12x plus 60. Divide everything by 3. So there's my boundary line. Let's find some values. Plug a 0 in for x, get a 20. And now I need to multiply something by negative 4 to add to 20 and get a 0. How about a 5? Yep, and 0. So it looks like my x values, I'm going to need the 5 as the maximum, so I'm going to jump by 2's. My y's I need to go by 20, so I'm going to jump by 2's. There's 20, and there's 10. Okay, let's graph my ordered pairs. 0, 20 is here, and 5, 0 is here. Connect the dots. Because it's less than or equal to, my boundary line will be solid. That's close enough. Now we will try 0, 0 to see if it works. Plugging it into the original, 12 times 0 plus 3 times 0 is less than or equal to 60. Is 0 less than or equal to 60? Yes, it is. So I'm going to shade on the 0, 0 side right here. So that's what my inequality looks like. What does it mean? That means I could buy, or Coach Riley could buy 2 pizzas and 10 soft drinks and stay under her budget. She could buy 4 pizzas and 2 soft drinks, because remember each one is 2 here, but she couldn't buy 3 pizzas and 10 soft drinks. Couldn't afford that. Couldn't afford 1 pizza and 18 soft drinks.